Hello students, welcome back to our channel, TutorHub, your e-classroom on YouTube. So today we'll be doing part 3 of balancing chemical equations. And there's a shortcut that I would be teaching you here, which I also taught in the previous videos. And if you haven't checked those already, please check the previous videos. And also, don't forget to subscribe to the channel. Click the notification bell so that you'll be alerted if I upload a new video. And like this video and leave a comment so that I would know how you found the lesson today and what topics you would like to learn in the coming days. And also, if you have any questions or problems that I might be of help, then you can leave that in the comment section. Right. So again, let's recall the MNO technique that is used for balancing chemical equations. Okay, chemical equations. The MNO technique stands for metals, non-metals, and oxygen and hydrogen. This means that when balancing chemical equations, we balance metals first, then non-metals and oxygen and hydrogen last. Okay, so following this technique we've shown in the past two videos, if you haven't already, please check that for more techniques and more examples on balancing chemical equations. We've shown in the previous videos and later in our next examples that these techniques work so well in balancing chemical equations, and it will make your life so much easier, and for sure you would love balancing chemical equations already, right? So for this particular example, we have C8H18 plus O2 to form CO2 plus water. Again, we divide the equation between your reactants and products. We start with the MNO technique. We don't have any metals here, so we go to the non-metals other than oxygen and hydrogen, and that would be carbon. And our carbon for the reactant side has 8 atoms. For the product side, it has 1. So we need to multiply this by 8 so that it gets balanced. Then, again, a technique that I showed you or I told you about before is to leave the last or the atom that is alone in the chemical equation and balance at last, because we can work on that later. Okay, that would be more convenient in the process. So we will work on oxygen last and deal with hydrogen first. So we have 18 hydrogen atoms on the reactant side, and for the product side we have 2. So therefore, because it's 2, then we put 9 there so that you have 9, 2 times 9, that would be 18. So that balances our hydrogen atoms together. Okay, so our carbon and hydrogen are balanced. Then we go to oxygen. Of course, we only have 2 on the reactant side, and on the product side, you have 8 times 2, that's 16, and 9 for this one, so that would be 25. Okay, so we need to multiply 25 over 2 here, because 25 over 2 times 2, that would be 25. So that balances the number of oxygen in the chemical equation. But as much as possible, we want to avoid fractions on the coefficients that we use in chemical equations. That's why to remove the denominator for this particular coefficient, the 2 here, we can multiply everything by 2, making the final chemical equation, becomes 2C8H18 plus 25O2 forming 16CO2 plus 18, that's 18H2O. So that becomes our balanced chemical equation. So how did you find that? Very easy, right? So just by following the steps, metals, non-metals, and oxygen, we're able to balance the chemical equation much easier, right? With the nuances, the techniques that I showed you, balancing the atom that is alone last, and ensuring that we do not have any fractional coefficients. That's another thing that you should keep in mind. Okay? Now, for our next example, here we can surely apply the MNO technique. We have two metals here. We have iron and sodium. So for the reactant side, we balance iron first. We only have one iron atom. And for the product side, we have only one iron as well. Okay? So this is balanced, this is balanced. Then we have sodium. We have one sodium atom in the reactant side and one sodium atom on the product side. Okay? Then we have a non-metal other than oxygen and hydrogen, and that would be our chlorine. Okay, so we're done with the metals. We go to our non-metals. That's chlorine. Our chlorine on the reactant side is 3, right? And on the product side, that's 1. So we need to multiply that by 3. Don't worry yet about the sodium. We'll get that sorted later. Okay, now we balance. We're done with the non-metals other than oxygen and hydrogen. Then we balance oxygen. Oxygen on the products on the reactant side is 1 here. And oxygen on the product side is O times 3. That would be 3. So we need to multiply 3 here to balance the oxygen out. So you notice that as we multiplied 3 to our oxygen and we multiplied 3 to our sodium a while ago, our sodium atom is also balanced together with it. So you notice that by following this sequence, the other atoms gets balanced out in the process. Okay, so oxygen is also balanced. Then we go to hydrogen. For the reactant side, it's 3. We have 3 hydrogen atoms. For the product side, we have 3 as well. So it's that easy to balance chemical equations. So you have 1 iron FeCl3, 3 sodium hydroxide, 1 iron 3 hydroxide, and 3 sodium chloride. So that's our balanced chemical equation. So I hope by now you're able to master the steps and find this very easy. Okay? Now for today, this is our last example for today. So we still follow the MNO technique. M, metals. We don't have metals. So we have non-metals other than oxygen and hydrogen. That would be phosphorus. P, for the reactants, that's 1. For the products, P is 2. So we need to multiply this by 2 to balance the phosphorus out. Then, for our oxygen, we have 2 for the reactant side and 5 for the product side. So we put a fraction 5 halves for our oxygen so that 5 halves times 2, that makes it 5. So that balances oxygen. Again, like in our previous example, we avoid fractional coefficients. That makes this equation, or that requires us to multiply a factor to this equation. So we need to multiply everything by 2 to remove the denominator 2 on oxygen. That gives us 4 phosphorus plus 5 oxygen to form 2 diphosphorus pentoxide. Okay, so that is now our balanced chemical equation. How was it? How was our exercise for today? I hope you found it very much easier compared to the last videos. But if you need more help, please watch the previous video, watch this video again. And of course, I'll be uploading more examples and more exercises on balancing chemical equations so that you'll be able to gain confidence and mastery on the topic. Remember, the more problems you solve, the more confident you become and the more mastery you have on the topic. Again, everyone, please don't forget to subscribe to the channel. That helps me a lot in creating more videos. Like the video, share with your friends, watch this over again until you master the concepts, and leave a comment. Let me know how you find our lesson today and what topics would you like to learn in the next video. So again, thank you everyone. Happy learning everyone, and see you in our next video.